We are doing our last section today in our probability unit. There we go. We're going to talk about permutations and combinations. Okay, we've kind of touched on this a little bit before with I believe ice cream toppings and outfits and stuff like that. If you have 3 outfits and you have 3 pairs of pants and 2 shirts, how many outfits can you make? How do you get 6? Multiply them together. 3 times 2. Beautiful. How about 4 sandwich choices, 3 sides, and 4 desserts? How many meals could you make? 48 different meals. Beautiful. We've done that part of combinations before. Okay? We have this many total items to pick from. How many combinations of these items can I put together? Okay? Of course, we got to take it one little step farther. It wouldn't be fun if we didn't. So the 2 previous problems, okay, they use the fundamental counting principle. This is the method of using multiplication to count. Write down what's underlined. It's easy to count numbers from a short list, but it's easier to multiply with a longer list. So sometimes if it's short enough, we could actually write out all the different combinations, like our first the outfit example, warm up. There we go. You could probably write out all 6 different combinations, right? The sandwich one, a little bit more complicated. Okay, more stuff going on. So when things get a little bit more complicated, multiplying is kind of the only way to go. So it is easy to count numbers from a short list, but it is easier to multiply with a longer list. My next example is about license plates. Okay, if you've seen license plates, you know they have letters, they have numbers. Okay, for a license plate, there are places for 3 letters and 3 digits, 3 numbers. Okay, how many possibilities are there for all these license plates? Well, how many letters are there? 26. There's 26 letters, right? Could they be repeated? Yeah, so they all have an equal chance of being used every single time. How many numbers can I put? Single digit numbers. 10 from 0 to 9. Okay, from 0 to 9 could be placed. So to figure this out, we're going to have to do 26 times 26 times 26, right? The 3 possible letters. And then 10 times 10 times 10, the 3 possible numbers. So the first 2 examples, technically you could write out the different combinations of the meals or the outfits, whatever. It is doable. This one, though, we get 17,576,000 different combinations. We're not going to write those down. Not going to happen. Okay, that's a lot of different license plates. Okay, this is a very basic combination where there wasn't really much other detail to go by. Okay, we are going to do permutations. Permutations, it's an arrangement of items in a particular order. So order does matter, which means things can't repeat. Okay, so suppose you want to find the number of ways to order the letters A, B, and C. So I can't go A, B, B, B. I use each number once. How many possible ways can I arrange those letters? 6? How'd you get that? You did it with your name? Oh, there you go. Yep. So you could actually write them all out. It could be A, B, C, right? Then it could be A, C, B. Switch them up. It could be B, A, C, or it could be B, C, A. C, A, B, or C, B, A. Right? We could actually write those down. There's 6 different possibilities. Okay? This is called a permutation. So it's an arrangement of items in a particular order. So everything has its certain spot, cannot be used again. So the sample size initially changes, right? There are 3 chances to put something in the front letter, right? But once you put the A there, you only got B or C to choose from in the second spot, right? Once you put one of those there, you only got one thing left to put in the last spot. So here, we don't replace it, sample size changes. Okay? This is also an example of factorials. So we're going to use factorials today. So because my sample size changes, it goes down by 1 each time we use something. Does that make sense? That is called a factorial. So if I said, hey, find 4 factorial, it is 4 times 3 times 2 times 1. 3 factorial, we just did it, is 6. 3 times 2 times 1, right? 9 factorial, 9, 8, 7, 6. Great, right? But what if the number's like 23 or 12 or 15? It can get a little messy. So guess what? There's a way for our calculators to help us. Okay? So a factorial uses the exclamation point as a symbol to get to that symbol. So we're going to practice with 9 factorial. You're going to push the 9 first. Then push your math button. Go over to the probability menu. So it might say PROB. Some of your older ones might say just PRB. And then you should see a exclamation point or a factorial symbol as an option. Okay, so everyone practice it. Push the 9, find your factorial, and make sure you get the 362,880 on your calculators. Anyone having issues with this? Because we're going to use this in formulas today. It's not the end-all be-all. You're going to have 2 or 3 of these to put into a formula. So make sure we know where to find it. We good? Questions? We found them? Beautiful. Okay, so factorials. So if I say, how many ways can you file 12 folders, one after another in a drawer, okay, that one gets taken away each time I put it in the drawer, right? This is a factorial. I have 12 folders, then 11 to choose from, then 10 to choose from, then 9 to choose from, okay? So to figure out this number of combinations, we're going to use factorial. What is 12 factorial? 4, 7, 9, 0, 0, 1, 6, 0, 0. Yes. So there are 479,001,600 ways to organize those 12 folders. I know, it's crazy. So how many ways? So if you have 8 shirts on a hanger, doesn't seem like a lot. How many different ways could you organize those 8 shirts? 40,320 different ways. Crazy. But again, it makes sense. If I have a red shirt, I can't use it again, but I could use anything else. Lots of options. Lots of different ways to go. We good? So we've done basic combinations, where you have a couple of things, you just multiply them together, right? We've done basic permutations, where order does matter, so factorial comes along, okay? Now, we're going to step it up a notch. Now with a permutation, we're going to pick them in a certain way, okay? So with the number of permutations of n times of a set arranged R items at a time. So we're going to be more specific in how we select things, okay? So for this, our formula is going to be n factorial divided by n minus r factorial. Your r value has to be bigger than or equal to 0, and then your n value has to be bigger than your r value. If you're ever not sure what to put where, your n is your bigger number. Okay, and we notate it with the NPR. So we have 10 students in a race. First, second, and third places will win medals. In how many different ways can 10 runners finish first, second, and third? No ties allowed. So I'm not asking just how many ways can the runners finish the race, because that would be a factorial, right? 10 factorial. This wants to know how many different ways can those 10 runners finish in first, second, or third. So there's a stipulation on how they're finishing the race. Does that make sense how this is different? Yeah, there's a certain way they're going to finish the race. What is your N value going to be? 10. It's how many runners. Good. What's your R value going to be? There's 3 different ways they can finish, first, second, or third. Make sure you can type this in your calculator, and we get the same result as 720 different ways to finish the race in first, second, or third. You can type it in exactly as you see it up there. 10 factorial divided by parentheses 10 minus 3, or you can just make that 7. 10 factorial divided by 7 factorial, and it should give you 720. Gillespie, did I answer your question?
No, what it was like, how do you do 10 to the power 2 better than 10 to the 3?
Correct. Yeah. Yep. And that's really just notation. Like you'll see on your homework, some of them have P's, some of them have C's on your homework sheet, because that tells you if it's a permutation or if it's combination. Because there's 2 different formulas. You know what's up?
Oh, I can't find the explanation.
Okay. Push your math button. Scroll over to the P. There. Scroll over the possibility. That's number 4. You might have been pushing second. Plus, don't push second. Just do the math.
Wait, did we use
What's that?
Did we use 3 to use 3 different places?
Right, because it's first, second, or third. That's 3 different places that they could finish in. We good? We were able to type it in? Beautiful. If you didn't have a graphing calculator, you'd have to do 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. So is it doable? Yes. If you don't have a graphing calculator, not the end of the world. It's just going to suck. But you can do it. All right, I want you to try this one. And how many ways can 15 runners finish first, second, or third place? So you do this one. All right, Ellie, what'd you get?
2,730.
Beautiful. 2,730. Yes.
I tried printing that in.
Then you put it in wrong. 15 factorial divided by 12. Yep, divided by. So 15 minus 3 is 12. And then go back to math. Enter. There you go. Yep. All right, combinations. They have their own fun little formula, okay? A combination is where a selection of order, the order does not matter, okay? So this formula, we have n factorial divided by r factorial times n minus r factorial. Okay, it's the combinations of n items of a set chosen r items at a time. So I have 10 marbles in the bag. How many different ways can I pick 2 marbles at a time? So we're not just picking one anymore. Okay, we're picking them out in groups. When it comes to calculator stuff, whoops, go this way. I would put my denominator in parentheses, otherwise your calculator, it does order of operations, right? Multiply and divide is the same group, it does it left to right. So it's going to divide before it multiplies if you don't tell it to do it different. So put parentheses around your denominator so it knows to multiply that together before you divide them. Okay, so what is the combination of 13 items taken 4 at a time? So I have 13 marbles in the bag. How many different combinations can I pick 4 of those marbles out? What is my n value? 13. What's my r value? It is 4. So 13 factorial divided by 4 factorial times 13 minus 4 factorial. 13 minus 4 is 9. So again, I put those parentheses there so you can see exactly how to type it in. If you type it in just like this, make sure you get 715. I don't know yet. I am leaning towards no, though. Great question. I will know the answer before tomorrow. So, because when you'll review for the test, you're going to need to know if you need to know it or not. So, I'll let you know. I'll talk to the other Algebra 2 teachers, see what they're doing. Make sure we're all on the same page. Anyone having issues typing this in? All right. Sweet. Then try those two. So they're not always word problems. Sometimes it's just given to you in the notation format. The C or the P tells you which formula you have to use. There's a C here, so we're using combinations. Do these and talk to your table people, see if they are matching you. All right, Elsie, you're my last person. Can you popcorn to someone else in the room for me? Sophie, what did you get for 8 combination 3?
Well, I would have to step where I'm going, where it was like 40,320 over 720.
So what did you get? 56. Do we agree? I agree. Yes, beautiful. Sophie, you get to popcorn to somebody.
That's what I put it down.
Tizzy, how about 9 combination 2? What did you get for parentheses? See the parentheses? Parentheses matter. Otherwise it's going to divide and then multiply. So you need parentheses on your denominator, like that. Because you didn't do 8 factorial and 3 factorial. Oh, let me see. You're missing a 3 at the bottom.
Oh, that's right.
Hold on. So you need an extra set of parentheses. The entire denominator needs parentheses around it. Lizzie, what'd you get?
I didn't do it yet.
Didn't do it yet. Do it now. I'm gonna come back to you. Kaylee, you got it? 36. Yes. 36. So for this one, your n value was 9. So 9 factorial over 2 factorial times 7, because 9 minus 2 is 7 factorial. Okay? If you're typing in this first one, if you're typing in this piece into your calculator, you need an extra set of parentheses around it. Okay? You gotta have parentheses around your entire denominator. So you should push divide parentheses every time. And then type it in and then close it off with another parenthesis. Alright? Otherwise, the order of operations are going to mess you up. Because you don't tell it to do any differently. Alright. Here we go. Now we have a word problem. Tizzy, this one's all you. So get ready. Coming back to you. Here we have a chemistry teacher. Divides her class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. And how many different ways can he select the drawings? So Tizzy, my first question for you, is this a permutation or is this a combination? So we think to ourselves, does order matter? Does it matter how he picks the drawings? No, it does not matter. So does that make this a permutation or a combination?
That's what
Which one does it make?
combination.
This is a combination. Yes. Good. This is a combination. So now use your combination formula to figure out how many ways he can select those drawings.
Oh.
It just says he picked 4 of them. He didn't say how. He just says he picks 4. The end. That's how we know it's a combination. All right, Kaylee, can you pick somebody in here for me, please? Tucker, what is my N value?
8.
My N is 8. Good. Popcorn.
Mason.
Mason, what's my R value?
4.
4. Popcorn.
3.
Do we have an answer yet? I know that was kind of fast. All right, when you're ready, I want the answer from you. So your N should be 8. Your R should be 4. What you got, Trey? Try again. So type it in. Bless you. Looking like this. 8 factorial over 4 factorial times 4 factorial. $70? Do we agree? I agree. Yes. 70 different ways you could pick those 4 drawings. Yes.
How do we know if we're picking a combination of the permutations?
If the order matters or order does not matter. Here, order did not matter. It didn't say how he was picking the 4 drawings. It just says he picked 4 drawings. Yep. It's not as detailed.
Wait, so combination is not as detailed?
Combination what?
Is not as detailed?
No. Nope. All right, this time you will draw winners from a total of 25 tickets in a raffle. The first ticket wins $100, the second ticket wins $50, and the third ticket wins $10. And how many different ways can you draw the winning ticket? All right, Trey, popcorn to somebody. If you don't know names, you can point. Just point to somebody. Right here. Ulatunde, is this a permutation or combination?
Permutation.
Permutation, how do you know that?
Because the value goes down each time they pick
Right.
the person.
Yeah, absolutely. So did the order matter? Did it matter which ticket they picked first? Yes. Notice how this one had way more detail in it? Right, Sophie?
Yeah.
Uh-huh. Stay with me. This one, it mattered. It matters what ticket got picked first, second, or third, because that changed the value of the ticket. Beautiful. All right, Ulatunde picks popcorn somebody. Octavius, what is my N value?
The N value would be 25.
25, good. Popcorn.
Richmond.
Richmond, what's my R value? How many different drawings are we doing? 3, good. So my N is 25 and my R is 3. Richmond, popcorn. Tucker? All right, you've already gone. You pop. Oh, you can answer if you want to, or popcorn to somebody. Jackson, back over here. Do you have the answer yet?
Yeah,
Work.
13,800.
13,800. Do y'all agree? Me too. Good. So the way we set this one up is we did, where is it? 25 over 3. No, it's not. No, it's not. 25 minus 3. Sorry, friends. Sorry. I got excited. It should be 25 factorial over 22 factorial. I'm sorry. There it is.
How do they show that?
and you should get 13,800. Okay, I know there's not a lot of work to show for these problems. The work you show me is how you set up the equation, okay? Because if all you do is write down a wrong answer, I can't tell you where you messed up. I can't tell you your end value was wrong. You got them switched, or you forgot to subtract, or your parentheses are in the wrong place, okay? I can't tell you where to go back and fix yourself if you don't show me what you're typing in the calculator, okay? So I know it's a calculator problem. I need to know what you're typing, okay? You and your table people, you got some summary questions. The first one I want you to discuss together is how can we distinguish between combinations and permutations? Talk to each other. I'm going to be picking somebody.
Are in arrangement. And combinations have no order.
All right, I'm going to go to Randy and Angelica. How can you distinguish between a combination and a permutation?
Permutations, order matters, and it's more specific. And then continuations, order doesn't matter.
Beautiful. I love it. Permutation, order matters, and they are more detailed because of the order, right? So they're going to tell you why there's an order that has to be picked. And then combinations, your order does not matter. Beautiful. All right, next question to talk about with your people, if you haven't already, is how do you calculate a factorial? Ready, set, talk. We know it's the exclamation point, but what does that mean? That's what you're talking about. What is that? I know this is the symbol, friends. How do I figure? If I didn't have a calculator and I told you to find this, how would you do it? You did not have a calculator. What, Mason? What?
4 times 3. Wait, no, yeah. 4
Yeah.
times 3 times 2.
4 times 3 times 2 times 1, right? That's how you find a factorial. You multiply all the values underneath it together, okay? Because you're taking a sample size. You're taking a 1 out of the sample size. Okay, so if you didn't have a calculator, you forgot it, there's none left, whatever, you could still do this. So typing in the symbol is great, but we got to make sure we remember what we're doing and what that's doing for us. All right, so for the rest of today, you're going to work on your assignment. We will review tomorrow and test on Wednesday. You have some word problems. You have some calculation problems. There are 17 total on here. Work together. When you are done, do not turn it in. Keep it. We're going to go over it tomorrow, and then I'll walk around and check it so you can keep it for your test review. Okay?